Protocols are rules that both the sender and the receiver and all the intermediate devices need to follow to be able to communicate efficiently. A simple communication will have only one protocol. In case of a complex communication, we divide it into several tasks and each layer have a separate protocol, and this is called protocol layering. In this diagram, we can see two people, Maria and Anne, trying to communicate. They listen and talk at the same time and they use air as a medium of communication. This is a very simple form of communication and they use only one layer to communicate. So we need only a single layer protocol in this scenario. In this image we see Maria and Anne trying to communicate in a different scenario. This is an example of complex communication. At layer 1, at both the ends, the postal department send and receive the mail. At layer 2, at both the ends, they encrypt or decrypt the data. At layer 3, at both the ends, they listen and talk. So, protocol layering enables us to divide a complex task into several smaller and simpler tasks. For example, if there is a security issue in the second layer, then only the second layer needs to be changed. The other two may stay the same thanks to modularity. A layer provides services to the higher layer, and a layer must be able to accept a set of services from the lower layer. Without protocol layering, each intermediate system would become as complicated as final system, which would increase the cost of the entire system. Let us look at the different principles of protocol layering. To achieve bidirectional communication, each layer must be designed to be capable of carrying out two opposite duties, one in each direction. For instance, listen in one direction and talk in other direction. Likewise, encrypt in one direction and decrypt in another direction. Similarly, send mail in one direction and receive mail in another direction. Let's look at the second principle. The two objects under each layer at both sides should be identical. For example, at layer 3, we see the plain text object identical at both sides. Similarly, at layer 2, we see the ciphertext object identical at both sides. In the same way, at layer 1, we see mail object identical at both sides. Now this layering helps us to have a logical connection. So here it gives us a layer to layer communication. So this logical connections help us to have an imaginary connection between the two sites, and it will help us to have a better understanding of the task of the layering we encounter in data communication and networking. In this example, here we can see, here we have a separate layer which deals with the plain text in both the sites, and similarly a separate layer which deals with encrypting and decrypting, and a separate layer for sending and receiving mail.